screen, Hella?
Yes.
Okay, perfect. Okay. So as you know, this is the course, right? It should look familiar. You know, you have your grade 12 announcements like on the left side, and then you have uh, course and resources. So I'm basically going to go over this course outline with you.
Hmm.
You can take notes if you need to, like of the important points. So let's see. So basically, this is 12th grade chemistry course. It aims to deepen your understanding of various topics, including organic chemistry, the structure and properties of matter, energy changes, rates of reaction, chemical equilibrium, and electrochemistry. Uh, Basically, you will enhance problem solving and investigative skills, emphasizing the importance of chemistry in everyday life and its impact on the environment. Um, and then this course is divided into units, basically like covering topics such as equilibrium, electrochemistry, structure and properties of matter, organic chemistry, like you mentioned, and energy changes and rates of reactions. The curriculum also includes a career and lab safety unit, which we're going to go over today, where students engage in an independent study project related to a chemistry-related career, fostering responsibility and planning skills. The instructional strategies involve problem solving, group forum discussions, inquiry, criteria development, readings, multimedia content, and independent research. And assessment methods include tests. So we are going to be giving you some tests, some assignments, reports. There's going to be virtual labs and observations. Okay. And the final examinations covers all strands, basically. So the grading system is based on knowledge and understanding, thinking, inquiry, communication, and application, with the breakdown of 30%, 20%, and 20%, and then 30% respectively. So knowledge and understanding is going to be 30% of your grading system. Okay. Thinking and inquiry is just going to be 20% of your grade. Communication is going to be 20% of your grade. And application is going to be 20% of your, 30% of your grade. Okay. Um, so you guys are basically evaluated on a percentage scale, with level 4 indicating a very high to outstanding achievement. Okay. Now, considerations for program planning include effective instructional approaches, accommodating diverse learning styles, and providing a variety of learning opportunities. So what is your learning style, Hella? Do you like to learn with like just, are you a visual learner? Do you like to hear things and then write things down? Are you hands-on? You like to do things when you learn? Um, so for cooking, do you do a lot of cooking, Hella?
A little.
Yeah. So you learn by doing things or just, just visualizing the ingredients and everything, and then you
Yeah.
remember it, right? That this dish is gonna require this ingredients, and then it's gonna become so yummy, right? So how do you learn basically? You learn to cook. How do you learn? How are you gonna be good at chemistry and learning chemistry? Okay. Uh, and then we have basically, we're going to learn about the role of technology in science. Critical thinking, critical literacy, and development of literacy and mathematical skills are important in this curriculum, and it also integrates careers education, so encouraging students to explore science related careers and their educational requirements. So what do you want to be, Hella? Do you know yet about, or are you still exploring about what kind of a career path you want to choose with in life? Like, do you want to go towards the uh medical? Do you want to go towards more like business? You want to go towards
Computer science or computer engineers.
Okay, wonderful. So computer engineers, that's good that you know. So basically, this class will help you develop your critical thinking, which you definitely need for your science, for your computer classes, okay? Critical thinking, critical literacy, and mathematical skills, okay? So this will be an important subject for you. It's a science, right? As we say, computer science, right? So the document basically, you know, covers cooperative education, health and safety in science. Academic honesty is really important. Um, so basically, there's no cheating allowed, there's no plagiarism allowed, and the consequences basically there's late if there are late assignments there will be consequences, okay? So turn in everything on time, and no cheating, no plagiarism, okay? And the difference between cheating is that you're basically copying other person's work, right? You are looking at previous tests to conduct your more recent test, and you're looking at their answers. So that's cheating. And then plagiarism is basically like you're taking somebody else's ideas and putting it as your own, which is no, okay? So even if there's an idea that you find like, okay, so this is an idea, you have to basically give that person a uh, a reference, like you have to have a reference page and you have to give that person credit that this is from this and this person, okay? um do you guys have a textbook that you're working with? Okay, so in a nutshell, uh we're covering advanced chemistry concepts while fostering critical thinking, practical skills, and awareness of the real world applications of chemistry. You got that? Do you have any questions?
No.
Okay, thank you. All right, so we're gonna go over safety and inquiry for labs. Uh, so the first video lesson, can you see my screen, Hella?
Pardon?
Can you see my screen where it says
Yes.
SCH for you lab safety?
Yes.
Okay, I'm gonna play this and I just want to make sure that you can hear it as well, okay? Here we go. Curriculum expectations for Okay, so lesson are listed here to apply your knowledge and understanding of safe laboratory practices and procedures according to WMIS. Can you hear that?
Yes.
Okay, perfect. Here we go.
So WMIS symbols, use appropriate techniques for using and disposing of lab materials, and use appropriate personal protection equipment. So your learning goals and success criteria are listed here. Students will be able to understand safe laboratory practices, and your success criteria, you'll be able to do this by analyzing WMIS symbols. So the first note when it comes to lab safety is that you are responsible. You are responsible for your own safety as well as for the safety of those around you. It depends on you. And failure to act in a safe and responsible manner will result in the removal of all science lab privileges. So one of the first rules for working in a chemistry lab is that there's no fooling around, no horseplay. And Professor Glickman, a lab practical joker, deftly places a single drop of hydrochloric acid on the back of another professor's neck. This is just a comic here. So that's something you don't want to do. Some other general safety precautions in the lab, right? Be aware of others in the lab. So no horseplay, no running, no misuse of equipment and chemicals and materials. No student should be in the lab or prep room unsupervised, no unauthorized experiments. Come prepared for your lab and read your procedure for any safety precautions before starting the lab. Also, there's no eating, drinking, or chewing gum in the lab. Right, you don't want, if you're working with harsh chemicals, you don't want to then, get that on your food or have it on your hands and then touch your food. And you also never taste unless you're directed to or directly inhale any chemical or substance you're working with in the lab. Do not sit on top of the lab benches, right? Please stay standing while doing your lab. Keep your work area clean and free from clutter when you're performing your experiments. And flammable materials such as butane lighters, matches, or otherwise are not to be used by students in class. With regards to safety equipment, safety goggles must be worn for all experiments. Contact lenses shouldn't be worn. Use your prescription glasses with goggles instead. Know the location of all safety equipment in the lab, including your fire extinguishers, eye wash station, first aid kit, fire exits, and fire alarms. Sharp objects. When using knives or other sharp objects, you always walk with the points or the sharp end facing down, and you cut away from your fingers and your body. With regards to electrical safety, do not place a cord where someone can trip over it. Never use electricity around water, and unplug all equipment before leaving the room. You must dress appropriately during a lab activity. Any long hair must be tied back, as well as dangling jewelry or baggy clothes. Shoes must be completely closed-toe, so cover the foot, no sandals allowed. Your teacher may require additional safety equipment, which must be worn depending on what you're doing. Right? So be sure to read your procedure and know ahead of time. All chemicals in the laboratory are to be considered dangerous. Do not allow chemicals to come in contact with your skin or your eyes, and do not taste or smell any chemicals. Check the label on all chemical bottles twice before removing any of the contents, and take only as much as you need. For handling chemicals, never return unused chemicals to their original container. No chemicals go down the sink, down the drain. You have to dispose of
When you're muted, I can't hear anything.
Sorry.
I'm sure we've all seen these.
Thank you for that.
before. So,
Let me
and they mean different things. So the actual symbol.
rewind that. Okay, here we go.
Symbol is then enclosed by a particular shape. So there's 4 symbols and 3 different shapes. These symbols indicate the type of hazard, if it's poisonous, flammable, explosive, or corrosive. And then the shape that that symbol is enclosed in is the degree of hazard. So if it's, is it just something to be cautious about? Is it a warning, so the second level of severity, or is it danger, right? That would be the highest degree of hazard. So for example, the poison symbol with the danger degree of hazard would be very, very poisonous and dangerous.
So Hella, for this one, it's the degree of hazard. Have you seen the stop sign when, your parents are dropping you off somewhere and, you stop in an intersection? It's the stop sign on the roads with so it's basically an octagon, right? And then
Yeah.
in red, it says STOP in big letters. So basically that means danger, that there are cars coming from another area and it's danger, so you have to stop, right? So this octagon here, this shape, next time you go, notice it. That means it's danger, okay? And same with the chemistry lab. Anything that's in this shape, it means danger. And then you have a diamond shape right here, right? That means it's a warning. And then you have the caution is in the upside down triangle. So these are basically like yield signs and stop signs. If you notice on the road, the yield sign means caution and it'll say yield on it. And it's an upside down triangle. And that means it's caution. Be cautious when you're turning, okay? So basically, you have your degrees of hazard, danger, a warning, and caution, okay?
You also have your WHMIS symbols, and this is the Workplace Hazardous Materials Information Symbol or System. So these are your WHMIS hazard symbols: compressed gas, a flammable material, an oxidizing material, an explosion hazard, harmful or fatal, biohazardous, infectious, corrosive, health hazard, harmful, or harmful to the environment. And they will be outlined in a red diamond. And those are the specific symbols for WHMIS. So when you're in the workplace versus the HHPS is a household products. So a review of some of our lab safety rules, right? No eating or drinking, wear your proper safety gear, report accidents that happen. Don't use any, right? No eating or drinking. Don't pipette by mouth. So pipette is where you squeeze through suction a little bit of a substance that you're measuring precisely from, one container to another, something like that. So obviously when you are doing that, you don't use suction by blowing in it or sucking in the pipette. You squeeze it with your fingers. Don't play mad scientist, so that goes with no horsing around, no horseplay or fooling around in the lab. And then know your emergency procedures. And that's all for this lesson. Have a great day, and I'll see you next time.
Okay, do you have any questions, Hella?
No.
Okay. Okay, now that we have gotten through this, there is an activity down here that we will be doing, or that you will be doing for homework, okay? So don't forget about this activity down here and then just turn that into me. So this is basically a WHMIS pictogram. We're gonna go over this, okay? So basically, it's the Workplace Hazardous Material Information System. So when you're in a workplace, especially a chemistry lab, there's a lot of chemicals, like um in your kitchen you have, or not in your kitchen, but in your laundry room, you have bleach, right? Bleach is very, like, you have to be very careful with bleach, not to get that in your eyes, not to ingest it. And, if you touch it, it'll cause skin irritation. And then you don't put that in with your like, you put that in only with the white clothes and not the colorful, right? Because if you put it in with the colorful clothes, the bleach will like stain it, right? Mark it, like it'll take the color off, right? So basically these signs, like, there'll be other materials in a chemistry lab other than chlorine or bleach, but you have your really, some of the chemicals that are in a chemistry lab can be very hazardous. So that's why there are warning signs here that will let what type of material it is. And then these are pictograms that let you know also. It's an easier way of seeing, visualizing what's in there and what can happen to that chemical substance if it's mishandled. So for this first one we're going to go over is called flame. So as you can see, there's a fire, right? It looks like a fire with the diamond shape around it in red. So that means that it's flammable. It's self-reactive. It's pyrophoric, and it's self-heating. In contact with water, it emits flammable gases and then organic peroxides. And then you have flame. You see the flame over the circle around here? That means that this is an oxidizer chemical. And then, of course, you have this explosion, right? It looks like a bomb, basically. So it's like an explosive chemical. It's self-reactive, and it's an severe organic peroxide. And then you see here, it looks like, a cylinder, right? Some sort of like a gas cylinder. So it's basically gas under pressure. It's like gas in a tightly contained, like tight container. And, if it's already under pressure. So if you put more pressure on it, it might explode, basically. So it's warning you that it's a gas cylinder. And then we have skull and crossbones, right? So that means that it's acute toxicity. It can be fatal, or toxic. So it's a very high danger area there. And then you have corrosion, meaning that if this chemical is dropped on a piece of metal, then it can corrode that metal or like eat it up, basically. And then you can, if it comes on your skin, that means it could basically kind of destroy your skin and cause a lot of burn on it. And also, if you get that in your eye, then it could cause serious eye damage. And then you have biohazard with this one with the circle around it. Basically, it has infectious materials, biohazard infectious materials. So these are in more like labs where people collect blood in your doctor's offices and things like that. So, and it could also be a chemistry lab or a biology lab, that basically has samples in it of human bodily fluids or other infectious material. And then we have this health hazard. It means, it's like it's in the middle here. It's a picture of like a man, and then you have a little like a round thing in the middle, and then some air, like some lines radiating out of it. That means that it's a health hazard. It can cause cancer. It can cause germ cell mutagenicity. It's an aspiration hazard. And then it's specific target organ toxicity. and also reproductive toxicity, as well as respiratory sensitization. So it's basically health hazard means it could affect any part of your body and organ systems and things like that. So you have to be extra careful when dealing with that. And then you have exclamation mark, means that it's irritation. It can cause irritation to skin. It can cause skin sensitization. It could cause acute toxicity. It can target a specific organ. It can cause drowsiness or dizziness or respiratory irritation. And then it is also hazardous to the ozone layer. Okay. And then we have this fish in there in this picture with the trees and everything. You see a tree and a fish. The tree looks dead and the fish definitely looks dead. So that means that it's outside in the environment. It can cause aquatic toxicity, okay? So this is what WIM's pictograms look like. And every chemistry lab and doctor's labs and things like that are basically required to have these in the labs to warn the workers that, you know, this chemical is toxic, or to just be careful. Okay. And then we have labels basically of these WIMS. So you know how labs or chemistry labs or workplaces get their chemicals or equipment once they're shipped from a site, a chemical maker, basically, it's shipped to the lab, and the labs are supposed to have a supplier label on the boxes, making sure that once someone is receiving that box, they're careful and that they know about the product and what it is. So, number one, we have your product, basically. Product name is going to be on there, or identifier. So basically, let's say it's a chemical called chlorine, right? You're familiar with chlorine bleach, right? It's also put in very diluted amount of it. It's put in pools. You can also dilute it a lot and put it in, you know, to water plants to kill off any mold and all things like that, so the plants can grow more. And then you can also use a very diluted chlorine to also clean your whites with, right? To bleach your whites with. So basically that, let's say the product name would be, or identification would be chlorine up here, number one, okay? Number two is going to be a hazard pictograms. So it's always going to depict that it's a danger. And see this one with the skulls and bones means that it can be fatal or toxic. Okay. And then you have the exclamation mark, which is basically a warning as well. Exclamation mark means that it's an irritation to the eye, skin sensitization, acute toxicity, hazardous to the ozone layer. Okay. And then we have signal words. So number three, signal words means it's danger, right? So the signal words that we had was danger, or the degree of hazard would be a danger. It was a warning, and then there's caution, right? So this one is danger. And then we have number four means that how are they dangerous, right? Hazarded statements, basically. So that means that it's a brief standardized statement of all hazards based on hazard classification of the product. So number four, we have fatal if swallowed, okay? Causes skin irritation, okay? And we have precaution, number 5. Precautionary statements. Basically, these statements describe recommended measures to minimize or prevent adverse effects from exposure to the product, including protective equipment and emergency measures. So precaution means it basically will let you know how to handle that product. You have to wear protective gloves, wash hands thoroughly after handling. Do not eat, drink, or smoke when using this product. You're not supposed to eat, drink, or smoke in a chemistry lab at all. Smoking definitely not anywhere. So we have store, how to keep it, how to store it, which is to lock it up. And then how to dispose of its contents in accordance with local regulations. And then it also tells you a precautionary statement such as if on uh if on skin washed with plenty of water, okay? If skin irritation occurs, get medical advice or attention. And then you have take off contaminated clothing and wash before reuse. And we have like things, precautionary statements like if swallowed, immediately call poison center or doctor and rinse your mouth. If it gets in the eye, you have to immediately rinse your eyes, okay? And then we have number 6, which is a supplier identifier. So where is this product coming from? It has to be like a company, right? Where this chemical is coming from. So basically that supplier identifier, which is company name, company address, and then company phone number, okay? And then we have workplace label. You know, you have to be warned, right? You have to make sure that you're safe in the workplace. And then we have, you know, of course, number 1, which is the product. Let's say chlorine, right? We were thinking chlorine, right? And then safe handling precautions, number 7, which is it's in the danger category. 7, so safe handling precautions like fatal if swallowed, it causes skin irritation. And it also may include pictograms or other supplier label information. So we have wear protective gloves, wash hands thoroughly after handling, do not eat, drink, or smoke when using this product, okay? And then we have reference to SDS, if available. So number 8 would be safety data sheet. So it's basically you have to refer to the safety data sheet for more detailed information on this product. Okay, and then now we're going to move on to WIMS and safety. So I want you to go ahead and read this. It tells you more about WIMS. So WIMS stands for Workplace Hazardous Material Information System. So the W stands for workplace, H stands for hazardous, okay? M stands for materials, right? And then what is it? It's an information system, IS, okay? So it is an information system implemented back in the 1988. It basically was designed to help students know more about safety and health hazards of materials that they use in the workplace. So WIMS gives workers and employers key safety and handling information in the form of special labels, symbols, and material safety data sheets, MSDS, okay, on potentially dangerous chemicals that are used on the job. You will come across controlled products that fall under WIMS legislation at school, you know, like, for example, chemicals used in your science classes, right? and at any workplace where chemicals are used. Okay, so it's like by law, the employer is supposed to provide you with this. Okay, in order for this to be a credible lab, you must have this information for the employees in that lab. Okay, and then you can go ahead and read about WMIS labels. And why they're important. And then we have all these WMIS symbols right here. We went over compressed gas. We went over flammable and combustible materials, like right here with this symbol. For example, hydrogen, methane, and propane. So it gives you some information on that. And then we have oxidizing materials right here with the O with the flammable on there. And then we have poisonous and so oxidizing material means oxy, like oxygen, has to be the oxygen. If they're exposed to oxygen, it releases oxygen or other oxidization substance. So basically, if it's in exposed to an environment or it's exposed to other chemicals, it will oxidize. And then we have poisonous and infectious material, which will be marked by, poison. As you can see, skull and bones, that means a person can die, right? And then toxic. So this looks like a T with a dot at the bottom. So toxic materials can cause toxic events or toxic effects. Basically, like it can cause irritation to eyes, skins, or lungs. It can also lead to cancers, asthma, organ damage, allergies, birth defects, things like that. And then, of course, we have the biohazard infectious materials, things such as AIDS, viruses, molds, fungi, contaminated blood, pathogenic bacteria cultures, things like that. And then we have corrosive materials. Corrosive means that they can put a hole, basically damage metal and also damage skin, physical damage to skin. Some examples include sulfuric acid, nitric acid, hydrofluoric acid, and some household cleaners as well. Water treatment chemicals and photographic chemicals. So, yeah. And then we have dangerously reactive material. So it's the R means reactive, and then it's like a tube, a test tube with these lines radiating. It's like thunder, right? Thundering out of it. So that means that it's dangerously reactive material. Okay, and then we have international hazard symbols down here, which, like we went over, danger has the octagon. That's the stop sign, right? And we have the warning in a diamond. And then we have caution in a upside down triangle. Okay. So we have the symbol with the skull and bones means poison. This fire or flames right here means it's flammable. and then it's explosive. It has like a bomb with like these lines coming out of it and dot, dot, dots. That means it's explosive. And then we have corrosive, means that it can injure your skin. So we have, and then we have the degree of hazards, which is danger, warning, and caution. So if it's a very, very strong chemical, it can be corrosive. And if it's a diluted chemical, you know, they might put a caution symbol on there. It kind of is in the middle, the degree of hazard, you know, it'll be in a diamond shape for a warning. Okay. And then we have material safety data sheet. That's very important. It's available in every lab, every chemistry lab, okay? And it's required by law to be there. So an MSSD sheets gives more details about the product or the chemical. Okay, and these are broken up into 9 sections. You have your product information, hazardous ingredients in the product, physical data, and then you have your fire and explosive hazard, reactivity data, toxicology data, basically toxicology properties, preventative measurements to be taken, such as, you know, you have to wear gloves, you have to have goggles on, you have to make sure that, you know, you zip up in a hazmat suit if you need to, if it's highly toxic. And then we have preventative measures to be taken and first aid measures if you're exposed to it, and then when it was made, and for more information, who can I contact? So basically, all this information is supposed to be protective. You know, you have to protect yourself, and it leads to safety. So the more information about the product, which is listed, the more safer your workplace is going to be. So, and then you have WMIS and safety worksheet. Do you see this worksheet, Hella?
Yes.
Okay, perfect. So I want you to go ahead and work on that and turn that in tomorrow, or yeah, if you have time tomorrow, you can do that. Okay? So that's under WMIS and safety. Activity, right? And you have your multiple choice quiz. I want you to go ahead and work on that after we get done as well, if you haven't already worked on it. Under the safety and inquiry lab safety. Okay, so you're going to work on these, on the activity and then your quiz, and then now we're going to go over career exploration, which is exciting.
Chemistry is known as the central science and holds a major in chemistry will lead college with knowledge of advanced mathematics and science concepts. As a chemistry major includes a combination of advanced math and science courses, and primarily from the lab will develop technical and analytical skills required for your future career. In the process of developing excellent laboratory techniques, you gain specific knowledge in traditional fields of chemistry. Because chemistry overlaps with many other subjects, you will also pick up skills that are useful in biology and medicine, physics and engineering, and geology and earth science. As we progress through your college career, you want to be mindful of the skills you are refining by majoring in chemistry. The most strong effort mathematical and numerical ability. You will also need to develop and refine the following skills: analysis and problem solving, time management and organization, written and oral communication, monitoring and maintaining records and data, teamwork, research and presentation, and IT and technology. There are many career paths that chemists can take, but some of the jobs directly related to a chemistry degree are analytical chemist, chemical engineer, healthcare scientist and clinical biochemistry, forensic scientist, pharmacologist, research scientist, toxicologist, and medical and clinical laboratory technician. Later in the video, we'll go into a few of these in more detail, but you can use this as a starting point for what you would like to do with your chemistry major. One of the easiest ways to begin your career as a chemist is by taking a job as a laboratory technician. This is a way for young professionals to start at the bottom of a company and work their way up with senior positions, generally requiring a master's or PhD. Furthermore, depending on your company, you might even be able to be paid to go back to school so that you can earn a graduate school degree and move up in the company. Lab techs are needed in a range of sectors, including but not limited to medical, clinical research, biotech, and environmental lab tech positions. Lab technicians are skilled workers that work with complex systems or perform highly technical, mechanical, or diagnostic tests in medical or scientific laboratories. Clinical and medical lab technicians are the two most common areas of work for lab techs. Much of your individual training will be learned on the job, but you will have a foundation of laboratory skills from your time in lab during undergrad. For example, if you're a medical laboratory technician, the tests you would be running would be orders for the patients and are based on recommendations from doctors and other healthcare providers. Patients usually have no direct interaction with the patients, but rather perform tests on human bodily fluids, tissue samples, and cells collected by nurses or other healthcare professionals to determine diagnosis and identify abnormalities. As a technician, you would then use microscopes, computers, and automated laboratory equipment, as well as keep detailed records of the data you compile. In May 2015, U.S. Bureau of Labor Statistics reported an annual median salary of $38,970 for medical and clinical laboratory technicians. The Bureau of Labor Statistics predicts 18% employment growth for these technicians from 2014 to 2024, which is much faster than average. Another job you can take is as an entry-level chemist. Entry-level chemistry jobs will often consist of working individually and as a team member to hypothesize, test, and draw conclusions. They may collaborate with people who specialize in other science-related fields, and especially in today's world, utilize the computing power available to help where applicable. For example, here's a job posting from Indeed.com for an entry-level chemistry position. One thing that I want to draw your attention to is the job requirements. What happens in almost all chemistry job postings is that every company will require some amount of laboratory experience. In order to fulfill this criteria, you will want to find internships either at your university or private companies so that you can develop these skills before you graduate. The average starting salary for chemists will vary by region, but as of 2010, the median entry-level salary was $44,000. Many people who major in chemistry continue on in their education or earn a master's or PhD because this is really where most of the job opportunities present themselves. One of the benefits of attending a PhD program is that you can usually get a good chunk of your education paid for by the university, if not all of it, in exchange for your time spent conducting research underneath a presiding postdoc. This is one way that top research universities like Stanford, MIT, UC Berkeley, and UCLA attract graduate students to attend their universities. You help the university develop new research, and they give you your education and eventually your graduate school diploma. Now, when it comes to being an analytical chemist, although you will be able to find some entry-level jobs, most of them will require a master's or PhD, with the most job opportunity and upward mobility to those with PhDs. Analytical chemists use a diverse range of methods to investigate the chemical nature of substances. The aim is to identify and understand the substance and how it behaves in different conditions. In the pharmaceutical industry, for example, you would be involved throughout the drug development process. This would include studying the physical or chemical properties of drug substances and formulations with a view to determining the quality and stability of drug products. Analytical chemists can find work in a range of scientific industries, and typical employers include chemical companies, biotechnology or contract research organizations, chemical and polymer manufacturers, environmental agencies, food companies, government agencies, hospital laboratories, petrochemical companies, pharmaceutical companies, and public health laboratories. And within these industries, analytical chemists' work may be carried out in areas as diverse as drug formulation and development, chemical or forensic analysis, process development, product validation, quality control, and toxicology. Analytical chemists earn an average of $71,700 annually. The highest 10% make around $120,600, while the lowest 10% earn around $41,000. Most analytical chemists work for private research and development firms, but as mentioned previously, many of them can be found at pharmaceutical companies. Other jobs that were not specifically mentioned are agrochemists, biochemists, inorganic chemists, and many more. For example, as an agrochemist, you would combine chemistry and biochemistry knowledge to improve agricultural practices like improved crop production, or making the process of taking raw goods and turning them into consumable foods and beverages. In a job as a chemist at a food or beverage company, you would likely implement techniques to improve quality assurance and quality control. An inorganic chemist would look at the structure and behavior of inorganic molecules, and this knowledge can be used in mining, geosciences, and the production of semiconductors. Now, a major challenge that new graduates face is landing their first job, and it usually comes down to that they fail to build the resume and build the proper relationships with people in their field to land a job. If you want to become a successful chemist, here's some helpful tips. First off, study hard. Study with students smarter or more talented than you. Although it might be challenging, it will greatly serve you in the long run. Then build relationships with your professors by visiting them during office hours. Join your school's American Chemical Society Club, or hold an office for that club if you can. Interview working chemists as suggested above. Join an established lab with plenty of grad students to conduct your undergraduate research. Observe the grad students and pick their brains when it comes to advanced lab techniques. Get your name on a publication or two. Seek an internship at a private company over the summer or during the school year if you can make it fit while you're in school. TA for a professor or see if there's research opportunities on your campus. If there's a career services department at your school, use it to extend your network and build relationships with potential employers. Attend an on-campus career fair. If you follow everything listed above, you're sure to have a leg up on the competition and almost guaranteed to land a chemistry-related job after a little bit of researching. You will develop valuable skills that companies will be more than willing to pay you for, but by far the most important thing you can do is build your career network. In addition to technical skills, you will also want to consistently improve your interpersonal communication skills. As a chemist, you will require creativity, interpersonal communication skills, which can be simplified to the ability to communicate clearly and concisely, self-confidence and motivation to investigate and solve complex problems, patience, and attention to detail. Outside of the careers listed, chemistry majors can move on to work in sales roles, do some sort of science-related consulting, teach, and many more. The challenge with these careers is that you have to be a little more creative in your job hunt and make the most of your social network. Major can lead to many great careers, and one thing that new grads can do to make their job search easier and more productive is to approach it from a project perspective. Avoid wasting time by developing a search plan and not just a resume. There are many different job sectors that chemistry majors fit into, and it is important for you to do your research and identify your interests as soon as possible. If you like this video, don't forget to comment, like, and subscribe, and I'll see you all next time.
Okay, so this was a little bit about the careers that are offered. And then you have a little activity here that they're so be sure to do this activity as well after we go over this, okay?
Our curriculum expectations for this lesson are listed here. To identify and describe a variety of careers related to chemistry, some examples listed there, as well as the education and training necessary for those careers. So with a education in chemistry, here is a list of some of the areas you can work in. Chemistry is a very large, very broad subject. And while it may seem specific, there is hundreds and hundreds of different career paths you can go into. So metallurgy, food chemistry, analytical chemistry, engineering, chemical engineer, product development or product tester chemistry, cancer research, environmental technician, polymer chemist, or oil spill advisor are just a few of the hundreds of examples. So here are some photos of the field of metallurgy, which is mining and purifying metals. So metallurgy is a career that is very hands-on, mining and purifying metals such as zinc, lead, iron, nickel, cobalt, copper, gold, and silver as well. So a career in metallurgy requires a bachelor's degree in chemical engineering or metallurgical engineering.
So Hella, I wanted to point it out since you want to go into computer science, you're going to be learning about hardware, right, of the computer. One of the things that are required for a computer to operate is chips, right? These little metal chips that are in the computer. And the phones, obviously, you know, the phones now are computers basically, almost. So they require something called a silicon chip, right? And it's a metal. And so there you have all the chemistry that is there in a computer. So now you understand the importance of learning chemistry.
And then again, here is your second option, a food chemist. So you'd like work in a laboratory and study and test food, do research with regards to food. So the purpose of a food chemist would be to, you know, make food better tasting, test the safety of different foods, better quality of food, better nutrition in our food. Food chemists could work for universities. They work for governments and in labs as well as private food companies. And they would need a bachelor in food science and chemistry. And here's some pictures showing an example of an analytical chemist or a chemical engineer. So again, working in a lab, testing or doing research on, you know, really hundreds of or thousands of different things, right? Every chemist would have their own research project in their own area that they're working in. So some examples of analytical chemistry and chemical engineering products. So for example, testing for blood, so for like doping or drug use for the Olympics. Developing cheap, long-lasting, high-quality CDs or DVDs, so just developing products. Designing product factories or paint, drugs, chocolate. And for this, you need a bachelor's in chemical engineering, specifically studying maths, physics, and chemistry, of course. Another one of those careers we talked about is cancer research. For this, you would need a bachelor's in biology, chemistry, or any of the life sciences, really. As well, usually that's complemented with a master's degree or a PhD in one of those medical fields, so pharmacology, oncology, toxicology, molecular medicine, or molecular biology. And a couple other of those careers we talked about, environmental technician, polymer chemist, or oil spill advisor. You can go ahead and do some research on your own about what these three jobs exactly are, right? So you can go ahead, take 5-10 minutes, do a little bit of research on each of these three things to see what they are and what kind of education is required of them. As well, you can do this with any other career in chemistry that was not talked about today that you are interested in.
Mm-hmm. So one thing I want to point out, Hala, oil spill advisor or environmental tech. So sometimes ships, you know how water and oil doesn't mix? So sometimes what happens is ships, they sink and they turn over or they crash. Ships, they become, you know, it's an accident. And the oil, it basically spills into the ocean, right? And that can cause a lot of damage to the environment of the ocean. And it could cause damage to marine life, right? Like fish can die, all these birds can, get oil all over them and can't fly anymore. Algae and the ocean floor can be affected and destroyed. So that's where, chemists come in and they devise up a plan to clean the ocean. There are some things that they can use, some chemicals that they can use, and some methods that they can use to clean their environments. So that's where it would become important.
However, the first step in your chemistry career is finishing SCH for you, right? Finishing grade 12 university chemistry, and then you will be well on your way to a career in chemistry, should that interest you. And that is all for this lesson on careers in chemistry. Have a great day, and I'll see you next time.
Okay, here we go. So once you're done with this, you have another assignment that you need to complete and submit. You click here, download your assignment. This is an independent study.
Hey, Miss, will you be posting the homework somewhere so that we can keep it?
Yeah, it should be all like through the portal, basically.
Yeah, just as a reminder so that I don't miss something. Because I
Yeah.
have a lot of things to keep up with. This is like my 5th course right now.
Oh, I see. Okay.
So I might miss a couple of things here and there, so I'd like to keep track.
Yeah, so after each section, there is a button called activity if you need to do an activity. So right here it says, after the end of this section, you have click here to download your assignment, complete and submit. So, let's see here. So it should give you instructions on how to submit these assignments. So just check under each, each section, just check whether they want you to continue, or there should be a button called activity here on Moodle. Like for this instance right here, we went under safety inquiry. So you have to finish this quiz, which will come to me automatically, this quiz online. And then we have WIMS and safety. Just go under each section, and then it will tell you, that you have to work on these assignments here, basically. So just be sure to look at every section and what they need you to do. This there's nothing for this. This is just a sheet that you need to go over. But once you come under WIMS and safety, you'll read through all of this material, and then it will take you to this work and this safety worksheet right here. And then you just need to finish this, like fill this out, and then you can email it here. Do you have email available on WIM on Averroes online login?
Not that I can see.
Okay. There should be. Okay, so you use Gmail, right? That's your Gmail. Okay,
Yeah.
your Gmail. Okay. Okay, so you are connected to the email basically. So yeah, you're gonna have to just scan the page and email it to me.
Okay, for sure.
Once you get done, you print out the page and you scan it and then send it to me. Sounds good?
Yes, of course. Do tell me if I ever miss anything. I try to
Okay.
keep track, but it's hard, 5 courses at once, so.
Yeah, I understand. How many courses for Friday do you take?
Friday it's only, yeah,
Is it
4.
only this class? Oh, four? Okay, good.
Yeah.
And what do you do usually on weekends?
The weekend is free, thank God.
Good.
But usually it's homework.
Oh yeah. Yeah,
Yeah.
exactly. I was gonna say you can use that time for chemistry homework since tomorrow is Saturday, you know. So you just have to see with okay, so when you're gonna become a computer scientist, you're gonna have to learn the skill of time management. So a lot of your work is gonna be online. You can work from home, right? So right now is a good way of pretending like you are a computer scientist right now, and then you're managing all your work in a timely manner. You're finishing your work on time and you're doing it from home. Because a lot of the jobs as a computer scientist are going to be from home. You have the option to work from home if that's what you choose. And I'm working from home. I worked from home for my other jobs, and I had to learn the art of time management. So this would be a really good activity for you is to learn time management when you're completing your assignments on the weekends and things like that. And you're tackling your course material. So it will help you as a computer scientist. Okay, good. So we went over career. So each chapter or each the subunit uh or each chapter I could say, like right here, there's going to be an activity. So at the end of this section, there's going to be an activity. Okay, so look for them. You have your multiple choice quiz and then your whims and safety right here. There's going to be an activity that you will need to do. Okay, remember the assessments? That was part of the assessments, the activities that are assigned. And then you have your career exploration is also going to be an activity, right? There's going to be an activity at the end of each of the chapters, basically. So assessment and click here to download your assignment, right? So there's going to be an activity at the end of basically all the sections. And I can also remind you as well of what to work for over the weekend, okay? Okay, and then we have reading. So this is something that you can read. to learn more about right here. So this, you can learn more about the Canadians that are in the chemistry field. So this doctor right here, Dr. Arya, her particular area of interest is halogen chemistry. So halogens are chlorine and bromide, basically bromine and chlorine. They occur naturally in ocean waters, and as they enter the ocean waters, they can also do runoff from land, like from human activities, like chlorine, for example. Like we use chlorine all the time to bleach our white clothes, right? Or even to clean with. So all of that kind of runs off from human activities. So, and it goes into the ocean, and the oceans emit these halogen into the atmosphere, and then they react with and destroy the ozone layer. So the ozone layer is a protective layer around our planet, and it basically destroys that. It blocks UV rays, okay, blocks too many UV rays to come into the earth. So when these these chemicals, toxic chemicals, get released into the air, they're destroying the ozone layer. Okay. So Dr. Arya and her students are trying to determine what kinds of halogens exist in Earth's atmosphere, how quickly they are produced and degraded, and what their major sources are. So, so once you find out the answers to all, like to learn more about these chemicals, they can develop ways to modify them, to modify halogens reactions with the ozone layer and other gases so that the halogens do less harm. And she's also studying sulfur, the elements that's on the periodic table, and its reactions with the ozone and hydrogen peroxide. So they're doing that through field studies, like outside in the environment. And they're trying to determine the impacts of such reactions. And she believes that you can enjoy nature intellectually and methodologically, and science keeps the mind alive because you're constantly learning. Science is fun. And then we have John Charles Polanyi. John Charles Polanyi basically provides some answers to study that faint light that is given off by molecules as they undergo chemical changes. So that actually led to the invention of the laser. And yeah, so he won half of a Nobel Prize for this, which is really cool. And yeah. And he's more of like a political influencer. He says that that human rights are integral to scientific success. Science must breathe oxygen of freedom. So yeah, people should be free to pursue science, basically. Okay. So we have this. Now I'm going to take about a 10-minute break. Is that okay?
That's fine. We finish at 7, right?
Yes.
Mhm.
So let's take a 10-minute break. You can have your water or tea. And then you can do a little bit of stretching. And then I'll see you back in 10 minutes, okay?
Sure.
Okay, and we're back. Hey there.
Nay.
Okay. So all right, I'm gonna go ahead and share my screen with you now. So we have now lesson. We're gonna go into our actual chemistry lesson. So our unit 1 is chemical systems and equilibrium. So basically in this unit, we will demonstrate an understanding of the concept of equilibrium, Le Chatelier's principle, and solution equilibria. We will investigate the behavior of different equilibrium systems and solve problems involving the law of chemical equilibrium and explain the importance of chemical equilibrium in various systems. So the big idea is that chemical systems are dynamic, means that they change, right? And respond to changing condition in predictable ways. Applications of chemical systems at equilibrium have significant implications for nature and industry. All right, so over here we have active learning, and then we have an interactive lab. So you can play with the interactive screen below. So over here in this screen, you will explore the properties of acids and bases. And then over here, my solution screens, which is you create solutions to explore the difference between strong versus weak versus dilute, acidic, or basic solutions. Okay, so you click on this one right here at the bottom, and then you click on each of these. This is pH, you test the pH of water. Let's say this is all water in a solution. The pH of water is always 7, as we know. Strong acids would be 2, a pH of 2. So and then you have weak acids here, pH of 4.50. Strong base will be 12, and a weak base would be 9.50. And then you have particles. Then the graph of water right here would be pH of 7. Okay, so you dip this in the water to test for the color. So water would be green, which is 7. Strong acid would be around this orange color. A weak acid would be around the orangish colors. Strong base would be like a blue color, and then a weak base would be like a dark green kind of a color. Okay, so you just go ahead and play around with all of this and look at how everything changes. Like this is an acid, and then you have a basic solution. All right, so you guys, you can just play around with that. This is the reset button. You can reset everything. Okay. And then next. We have this, the subject is going to be significant figures for Unit 1. So we've kind of worked or kind of played with our lab, interactive lab a little bit. And then we're gonna go ahead and um, so the success criteria for this unit, it's basically read the learning goals for this unit, and they will basically help with develop a common understanding of what success means in this unit. This valuable information will be used when considering your understanding of the rubrics, checklists, and other assessment tools. I will use to assess and evaluate your work. So the success criteria, you must ask yourself, describe a specific term, what successful attainment of learning goals will look like for you. So you must ask yourself, these are the learning goals. If I achieve these learning goals, what does that achievement look like? Okay. So we're going to look over learning goals. I would like you to give 2 or 3 success criteria based on these learning goals. So collect 4 to 5 learning goals from the unit. For example, you could write, I can consistently apply grammar conventions to my writing. And then collect 4 or 5 learning goals from the unit and what does success in this unit looks like to you. So you can, basically figure that out. And then we have the video lesson for significant figures.
Hello everyone and welcome to 4U Chemistry, SCH4U. We're starting off with Unit 1, which is Chemical Systems and Equilibrium, and this is Lesson 1 on significant figures. So let's get started. Our curriculum expectations for this lesson are given here.
So use appropriate numeric, symbolic, and graphic modes of representation and appropriate units of measurement. Example, SI units, imperial units, and express the results of any calculations involving data accurately and precisely to the appropriate number of decimal places and significant figures.
More specifically, our learning goal is students will be able to apply significant figures in quantitative circumstances, and our success criteria. So at the end of this lesson, you should be able to perform calculations involving significant figures in different quiz questions. So significant figures are the digits in a measurement or in a number that are known with certainty, plus the first estimated digit. So we're looking at the true or accepted value in this example is 21 centimeters. And we're looking at 3 different groups of data. The first one has 21.00, 0.01, another 21.00, 21.02, and 20.98. And let's say these are different measurements for anything really in centimeters. So the average, we take the average, we add up all the numbers and divide by the number of numbers, and we get 21, right? That's our average. So it's accurate and it's precise. However, if we look at group 2, we see those numbers, our average is still 21. But we have a different set of numbers here. It's accurate, but it's not really precise, right? The numbers are all over the place. Then you have group 3. Our average is much lower, 17.49 centimeters to be specific. So it's precise, but it's not particularly accurate. This will make some more sense as we go through more examples. So again, significant figures is what we will use a lot when we do our calculations in chemistry. It's the number of digits or the number of significant figures the number of digits in a measurement that are known with certainty, plus the first estimated digit. So we want certainty and accuracy when we do chemical measurements. So for determining the number of significant figures you need to put in your answers when you do calculations throughout this course in chemistry and physics and other scientific mathematical calculations, you have to follow a list of rules. And here are the first two, that all non-zero digits are significant figures, right? They matter. So for example, if we have 345.26 grams, how many significant digits are there? Right, well, there's 5 digits and they're all non-zero. They're all a number between 1 and 9, essentially. So 3, 4, 5, and 2, and 6. There's 5 significant figures. And our second rule to follow is that any zeros that are before non-zero digits are not significant. So if you have 0.00023, and I ask you how many significant figures is in this value, in this number, it's only 2. So you can scratch out all of the zeros. If it's a bunch of zeros before a non-zero digits, right? They are not significant if they're before our non-zero digits. Here's a few more of our rules. So zeros, or rule number 3, zeros between significant figures are significant. So if you have 108 millimeters, for example, that 0 is significant. There's 3 significant figures there. Number 4, zeros after non-zero digits and after a decimal are significant. So even though they're zeros, if they're after non-zero digits, they are significant. So if we have 18 or 181.00, I think that comma there is just a mistake. Or sorry, no. Yes, the comma is a mistake. So 181.00, there's still 5 significant figures there, right? Because those zeros are after a decimal or after the non-zero digits. And another example here, zeros after non-zero digits, but before the decimal are not significant. Right, so in this case, there is no decimal place, and they are after the non-zero digits. So for example, 1200, 1200, there are only 2 significant figures there. Those zeros are not considered to be significant figures. Another example is if you're looking at scientific notation, we look at that first number, right, 1.810, those are all significant, so there's 4 significant digits there. And another instance, and if there is that little dash or a bar above a 0 at the end of a value, so in this instance it's 1 for 18,100, but there's a little bar or a dash on top of that last 0, then that 0 and any ones after that are not significant. So here we only have 4 significant figures. Let's look at some sig-fig examples. So number 1, 82, how many significant digits? Well, they're both non-zero digits, so there's 2. You can go through some of these on your own, but I'll pop to number 3, for example. There is 1, 2, 3, 4, 5. Each value is significant. Number 4, remember all the zeros in front of the non-zero digit are not significant, but ones that are in between 2 non-zero digits are. So therefore the 60085 are the only significant figures there. So there's 5 of them. Let's look at another example, to number 7, right? The zeros in front of the 1 are not significant, but the ones after it are. So the 100200, there's 6 significant figures there. You can go through the other examples on your own. And some more examples here, 10 to 20. Here we have the number 11, scientific notation, 1.26 times 10 to the power of -5. We'll just look at 1.26. That's 3 significant figures. Let's look at number 13, 4.6583 times 10 to the -7. All of those are non-zero digits, the 4, 6, 5, 8, and 3. So that's 5 significant figures. Number 16, right? All the zeros before the non-zero digit are insignificant. So that 0.000 we just scratch off. And then the rest are significant. So the 1, 2, 5, 0, 0, 0. So we have 6 significant figures. Another example, let's look at number 19, right? The zeros that are in between or after those non-zero digits are all significant. So we have 1, 2, 3, 4, and I think they say 4 here because if there was a bar, that dashed line above that last 0, I think is what there was supposed to be 1 there, that would be non-significant. So then just the 4, 0, 0, 1 would be significant. There would be 5 significant digits if there's no dashed bar above that 0. So rules, when you do calculations throughout this course, you need to be putting your answer with the correct number of significant figures. So there's rules when you do calculations. So let's look at multiplication and division. The rule is that the number of significant figures in the answer is the same as the number with the lowest number of significant figures in the question. So for example, we have 65.01 meters times 3.4 meters. Right, so which number in that question has the lowest number of significant figures? Well, that's 3.4. That's 2 significant figures. So we need to put our answer in 2 significant figures as well. And if you cross off a number in front of the decimal, right, replace it with a 0. So our answer needs to be with 2 significant figures. So in this case, we get an answer of 221.034, but that's not in the correct number of significant digits yet. So we need to round in order to put our answer in the proper significant figure. So we only want 2, so we can round that to 220, right? Remember that's a 0 that is after the non-zero digits, but before the decimal, so it's not significant. So 220 meters squared is how you would express your answer in 2 significant figures in proper form. So rules, when you do calculations throughout this course, you need to be putting your answer with the correct number of significant figures. So there's rules when you do calculations. So let's look at multiplication and division. The rule is that the number of significant figures in the answer is the same as the number with the lowest number of significant figures in the question. So for example, we have 65.01 meters times 3.4 meters. Right, so which number in that question has the lowest number of significant figures? Well, that's 3.4. That's 2 significant figures. So we need to put our answer in 2 significant figures as well. And if you cross off a number in front of the decimal, right, replace it with a 0. So our answer needs to be with 2 significant figures. So in this case, we get an answer of 221.034, but that's not in the correct number of significant digits yet. So we need to round in order to put our answer in the proper significant figure. So we only want 2, so we can round that to 220, right? Remember that's a 0 that is after the non-zero digits, but before the decimal, so it's not significant. So 220 meters squared is how you would express your answer in 2 significant figures in proper form. However, the first step in your chemistry career is finishing SCH for you, right? Finishing grade 12 university chemistry, and then you will be well on your way to a career in chemistry, should that interest you. And that is all for this lesson on careers in chemistry. Have a great day, and I'll see you next time. However, the first step in your chemistry career is finishing.
So rules, when you do
SCH1,
calculations throughout this
finishing
course,
grade 12
you need to be
university
putting your
chemistry,
answer
and then you
the
will
correct
be
number
well
of
on your
significant
way
figures. So
to
there's
a
rules when you
career in
do
chemistry
calculations.
that interests you.
So let's look at
And that is
multiplication
all
and
for
division.
this lesson on careers in
The
chemistry.
rule is that the
Have
number
a
of
great day,
significant figures in the answer is the same as the number with the lowest number of significant figures in the question. So for example, we have 65.01 meters times 3.4 meters. Right, so which number in that question has the lowest number of significant figures? Well, that's 3.4. That's two significant figures. So we need to put our answer in two significant figures as well. And if you cross off a number in front of the decimal, right, replace it with a 0. So our answer needs to be with two significant figures. So in this case, we get an answer of 221.034, but that's not in the correct number of significant digits yet. So we need to round in order to put our answer in the proper significant figure. So we only want 2, so we can round that to 220, right? Remember, that's a 0 that is after the non-zero digits, but before the decimal, so it's not significant. So 220 meters squared is how you would express your answer in two significant figures in proper form. However, the first.
Okay, and with the addition and subtraction, the answer has the same number of places to the right.
Or chemistry career.
The answer has the same number of places to the right of the decimal as the number in the problem with the smallest number of digits to the right of the decimal. So for example, if you're adding 65.01 grams, which is two significant places, plus 3.4 grams, which is one significant place, it turns out to be 68.41 grams. And the answer that you're going to put it in is going to be 68.4 grams because it's one significant place. Right. It's the number of digits to the right of the decimal. So which is 0.1 grams, that's two places. 4 grams, that's one places, and then so that would be one place, and it's 0.4 grams. So the smallest number of digits to the right of the decimal, which is one place, right? So the answer will be in just one place. So with addition and subtraction, you have to remember the smaller one, the smaller number of digits to the right of the decimal point. You count those as significant figures. And the smallest number, the smallest place, basically, is what you're going to put as your answers. So this is one place. This is two places on the right of the decimal, 1, 2. And this is one place. So out of these two, the smaller one is one place. So your answer is going to be in one place significant figure. So that's after the right of the decimal point, right? So it's going to be 4.4. Your answer is going to be 68.4 grams. Okay, and then we have an activity at the end of this lesson, which you will need to also do over the weekend or tonight. And then we have, for this activity, there's a multiple choice quiz, okay? Hella?
Yes.
So you're going to finish that quiz that I just showed you, right?
Yeah, for sure.
Okay, cool. Awesome. So I'm glad that we got this strong start to our learning journey here. And what I can do is I can get you a summary of, it's just so basically after every activity, like after every lesson that you go through, go ahead and complete every activity listed under each section, okay? So there is something that you can do after each section. Okay, so you have your learning goals and objective, your video lesson that we just went through, and then your